Hello race fans, it's Peter Partee from Partee Racing. I'm here with the head of engineering, Chris Knerr, to talk about our BMW S65 carbon fiber plenum. Now Chris, this was your design, your handiwork. Tell us some of the basics about the plenum.
Yeah, so first of all, it's constructed from aerospace grade composites, Pre-Preg carbon fiber. It's processed in an autoclave at 9 times atmosphere. It's baked at 120 degrees Celsius, which is 251 degrees, something like that, Fahrenheit. And that stuff all matters as far as like the durability of the component, right?
Why? Tell us a little bit why.
Well, so the pressure, what separates Pre-Preg from, say, an infusion, for example, because there are very high quality infusions out there.
Sure.
But how this kind of stands head and shoulders above any infusion, in my opinion, is that by being processed originally at such a high heat and under so much pressure, you are able to crush the layers of composite, like the individual toes of the fabric. You're able to crush them into each other more.
Right.
And that creates a stronger part because it takes more shear force to actually get the two layers of carbon to separate. It also makes it lighter because there's less actual resin in there, right?
Sure.
If you were to process this at atmosphere like you would in an infusion or a more traditional layup, it would be riddled with voids because there's not enough resin in that application to get it to look right.
So it's heavier and not as, that would be heavier and not as strong. This is lighter and stronger.
Correct. Additionally, this specific pre-preg that we use is UV stabilized out of the box, right? So in addition to the clear coat that we apply, which is high solids PPG clear coat, it's also foundational UV resistant. So realistically, the clear coat would have to peel off, and then it would take another decade for this thing to start to turn yellow. So you've got a lifetime part just by default from that perspective.
Awesome. I think we've all seen carbon fiber under a hood and otherwise that turns yellow, and oh boy, that's not something you want.
Right. And you know, honestly, if your plenum is seeing over 250 degrees Fahrenheit inside the engine bay, you've got problems. So yeah, those are some of the big benefits of the pre-preg carbon. From a design perspective, I started with the OEM design because I think it looks great. I wanted to kind of clean it up. I wanted to keep kind of the aggressive lines that it has, these cutouts. I think it looks really nice, but also I wanted to clean it up a little bit to let the twill of the carbon kind of shine.
Sure.
It serves more than just an aesthetic function too, though, because we've got these GT style velocity stacks rather than the OEM curve design. And I think that these work really well. I think if I remember correctly, we gain about 10 foot-pounds of torque in the mid-range or the low to mid-range.
Surprisingly, yeah.
Yeah, we end up making OEM power at the top. You know, if you don't gain any horsepower at the top end from this thing, you don't lose any either, which is important. Because
and this was, to be clear, without any tuning whatsoever. This was just installing the plenum, and then we started running it on the dyno, and we had this curiously higher level of torque before 5250 at the crossover point, and then it was also a smoother torque line.
Right, because there was a dip with the OEM plenum, and this plenum kind of made it all perfectly flat.
Now you attribute that in part to the elimination of the kind of, I don't know, the little cutouts that go in the stock plenum on the side.
So it's everything kind of, it's no part on its own works by itself, right? So it's a sum of its parts. I think what we're seeing here is, you know, we've got the past 90-degree rounded edge, just like we do with the S62.
The bell mouth there,
and you know, that would be a little bit restricted if we still had those ribs inside here really low and close to the top of these velocity stacks.
Got it.
By opening it up, we give it more room up there to actually pull in fresh air, and all of these things work together to create a plenum that performs pretty nicely.
Why not make these out of carbon fiber, Chris, like some other manufacturers do?
So there's a bunch of reasons, but ultimately we care about quality and making a part that's going to last the lifetime of a car. And I worry about the intense vibration that these things are going to see when you're pulling, you know, 8,200 RPM, and you know, over the course of, you know, the next 10 years or longer. The pressure that you have on here, and then on top of that, you know, whenever you service your engine, if you have your plenum off for any reason, you're releasing and you're reclamping and you're releasing. And any carbon tube is going to have seams around themselves, right?
Yeah.
And those seams over time will start to weaken and fail with those stress cycles and those heat cycles and those vibrations. By using billet aluminum as our joining material, there's no concern of that ever happening. This is not going to fail.
Now, these velocity stacks screw into the base plate,
That's correct.
And so they could become unscrewed, right?
In theory, it's possible, but we use green Loctite on all of these. They're, once they're in, they're permanent. This part's never coming apart. And that, that raises the question, well, what happens if something ever needs changed? The good news is the holes in the bottom of the plenum are just big enough that this can actually come through. So even though this part will never come apart, you can still remove it and replace it.
Drop it out of the bottom.
Exactly.
Perfect.
We opted to not use carbon for any of these mating surfaces, as, like you said, other manufacturers do.
Yep.
It's more expensive. Each one of these on the bottom here, every single piece has 2 pieces of aluminum on the outside and then one on the inside, right? So it takes a lot of time. We're running our lathe a lot to get these things all made.
Sure.
But what I want to see is positive connections that aren't just relying on adhesion of a glue to hold things together, but actual mechanical lock of metal on either side of the carbon. So effectively, the carbon itself has to break in order for things to come apart. Because the last thing I ever want is one of these velocity stacks to fall out or fall apart or get a vacuum leak or anything else.
Now, Chris, in fact, with the S62 stacks, the velocity stacks that were there, we actually started off with using carbon fiber flanges for those stacks, didn't we?
Right, and that kind of educated this decision because they failed instantly.
We never sold those to the public.
Actually, I remember the pit in my stomach when you sent me a video of you breaking them with your bare hands, and I remember being nauseous over it.
Well, it's a little extra strength, but yeah, no, they weren't durable enough, is what it boiled down to, and that was even with MMA.
Correct.
Right.
Yeah.
And so, again, these are going to be more durable. They're not going to come apart, especially with the green Loctite. If you do ever need to remove them, you can drop them out of the bottom. Got it. Now, there have been some changes to the plenum over time, some slight modifications here and there based on user input, feedback. What were those?
Well, it was more than just user feedback. It was also our own standards, right? Initially, when we first started doing these, we were doing them in one piece. What do I mean by that? The top and the bottom of the carbon was all entirely molded in one piece, in one shot, with a closed mold. And a lot of people told us it was impossible.
Right. I remember.
The fact of the matter is it's not. We did it. We sold several of those, made one piece like that. The problem was it was inconsistent, because the only way to access the part as you're vacuum bagging it and getting it all ready to process in the autoclave is through the inlet. And so there we were, shoulder deep in each one of these plenums, trying to get all the vacuum bags situated. And so we decided to go a different route, because it was... We had a failure rate of what, 1 in 3?
1 in 3 or 1 in 4.
Yeah, and probably we could have sold those and they would have been fine. Most people would have never noticed the defects, but we did, and it was unacceptable to us.
So there was really no way to maintain quality if we were going to continue to use the one piece. And by quality, I mean, the texture, the form, everything being exactly as we expected it.
Without making the parts prohibitively expensive. We could not do them that way. And
without throwing away 1 out of every 3 or 4.
Right. And that, it's something like 24 hours of labor that goes into each one. And that's it's obscene to waste that much time. So what we decided to do is start over and make more billet molds. I think we've invested probably $100,000 in our billet molds at this point.
Don't remind me.
And it wasn't a complete change, but it was a minor change in that now we have a top piece and a bottom piece that need to go together and have mating surfaces that match up to each other, right? So we needed to have a mold that not only would make the top piece, but also could make a lip on the top piece to go into the bottom and still allow the carbon to actually escape from the mold without being mechanically locked in.
Right, and if you look very, very closely at the front here, you can see this faint little line where it connects, but oh boy, is that smooth.
Right, and that too was a challenge, because other brands have their seam follow this edge and then follow right across the front of the power hump and all the way around. And That is the easier way to do it, absolutely. But the problem is it's unsightly, frankly.
Right.
I think that it draws too much attention to that seam.
This you can barely see, and it's along the edge here,
Correct.
where you would kind of expect an edge to be.
And I made the choice to drop the edge down and follow the outside of the inlet.
Right.
And it looks great, but we had a couple failures as a result of that.
Yeah.
One thing I didn't expect is people to absolutely torque the crap out of their hose clamp. And
you mean on the front piece here, attaching it to the intake? Yeah.
Correct. And so we had a couple people that were over torquing them, and it actually caused this seam here to break. Barely, but it was breaking. And so we had to make another change. We had to make another mold. And now, as you can see, I don't know if you can see it in the camera here, there is another piece of carbon. There's actually a solid ring that's molded separately that goes on the inside of here to act as a structure for everything to clamp against. And
so now people can crank down as much as they want to, and it's not going to split the plenum.
It's never going to fail. Okay. And the nice thing about it is the overall thickness of that is about what the OEM plastic piece is, so there's no real negative effects there.
No impact on airflow.
Correct.
Got it.
So that's kind of how we got here. At this point, we've got it down to a science. We're able to crank these things out pretty fast. From start to finish, it's about a 4-day process.
So we've also done some testing of this plenum without any tuning, and it seems to be functionally superior to the stock unit by virtue of increasing torque at the lower RPM range before the 5250 crossover by about 10 foot-pounds, right?
Yeah, that's correct. We did gain about 10 foot-pounds in the 3,000 to 4,000 RPM regime.
And it was a smoother curve as well relative to the stock piece.
Yeah, exactly. So there's a little bit of a dip there in the stock dynograph.
Yeah.
By changing to this without tuning, without anything special happening, it flattened it out, and we stay pretty much exactly the same as OEM everywhere else. We don't gain or lose power anywhere, which is about what we've been seeing with all of the aftermarket plenums. The other guys, they're an exact replica of OEM, and it performs just like OEM. There's some others that are a lot larger and a lot rounder, and some people say they do, some people say they don't. I haven't seen anything either way. But what we do know is that ours performs better than stock.
Right, and surprisingly performs better than stock below 5250 RPM. Right. So it makes the engine a little torquier than it otherwise would be, even with the vertical velocity stacks.
Right.
Kind of a little opposite of what we expected. And again, that's without tuning. With tuning, I suspect you could take that low end torque that we're experiencing and convert it into higher end performance, higher in the RPM range.
Yeah, I think it's certainly possible.
So again, what we have is a really nice, not replica of the stock plenum made out of Pre-Preg carbon fiber plenum. It looks beautiful. You can put your M emblems up front if you want to, but it's a much smoother look because you've eliminated the ribs. We've got moderately better performance than stock, and it's a higher quality unit, much more durable because of the aluminum fixtures as opposed to the carbon fiber, which, as you said, over time, as you're clamping and unclamping, those are going to wear out. Ours is reinforced in the places where it needs to be, so that when you're clamping and clamping, it's not going to experience any kind of fatigue. And ours is priced comparably to the market as well. Yeah. So. And again, it's not the one-piece unit that we started off with, but it is, we believe, at least as strong as the one-piece unit. And the consistent quality that we can produce is what I think everybody's come to expect from our carbon work.
Agreed, 100%.
Our carbon fiber S65 Plenum is available on ParteeRacing.com in the carbon fiber parts section. Thank you.